Sorry. Okay, hello everyone. So today we have Sash. Actually, his really long name is Alexander Stasic. Is that correct?
Yes.
Okay, not too bad for a Spanish guy. So I think maybe you can correct me if I'm wrong, but you do do a lot of programming in your free time. And
Yes.
you do some gaming as well.
Yes.
Okay, and you can also speak like Russian and Ukrainian?
Yes.
So how is that?
I was born in Ukraine and lived there until I was 10, and then I moved through to Dundee afterwards.
Okay, okay, that sounds good. So then, I don't know if we have a lot of people speaking Ukrainian here. Maybe they can practice with you.
Yeah, if they want, always welcome.
Okay, thank you very much. So now, currently, you're working for FireMatePass as a tools engineer?
Yes.
All right, and like I think today you're going to show us like some of the things you're trying to do there and different things, different practices.
Yes. So generally, it'll be a talk about my humble experience in deploying an infrastructure of web applications, and then a review of how we do infrastructure and deployment at FireMatePass itself.
Okay, that sounds very good. So looking forward. Go ahead when you want.
Cool. Right. So hello and welcome to my talk. I've been interested in the infrastructure and deployment kind of side of things for the last year or two now, and I've been increasingly more and more enjoying that side of things. So this is what we'll be talking about today, just the automating the deployment infrastructure of the parts. As I've been introduced, I'm Sash. I also go by that other long name sometimes when the police ask. I'm a tools developer in FireMatePass, and that entails providing a service to other developers. So our aim is to help other developers deliver faster and easier. Here's my GitHub and Twitter if you wish to have a look in there. So a couple of disclaimers about the stock. These are my experiences alone, and I don't really want people to take this as best practice. I mean, if it works for you, then fantastic. But at the same time, if it doesn't, this is just yet another way we can do things. And also, this talk was originally designed for a PHP user group, so we'll be focusing pretty much on deploying web applications specifically. Okay, so let's begin. The audience, I'm guessing, has various levels of experience in deployment, but I would prefer to start from quite the basic ideas in it. So to start with, let's just ask the question, what is deployment? Like, who can tell me what deployment actually means to them in terms of web applications? And that's the question to the audience. Anyone got any ideas what deployment is or what it entails?
Asking Sash.
Okay, here we have like a bunch of people. Anyone?
I guess it's to do with the installing and setting up an application on a server.
Yeah, absolutely, yeah. Anything else? Like, can you say why would we deploy things to start with?
Seeing a change out in the real world.
Yeah.
So I guess your fantastic application that you have developed locally, and you want to have some people using that.
Yeah, perfect. That's exactly it. And then what would deploying involve for you, for example?
So you're going to take some things that you've got locally, you're going to transform them a little bit, you're going to change config, you're going to create a package if you're kind of old school, and you're going to move it over and dump on a server somewhere.
Yeah, that's one way of doing it, absolutely, yeah.
What if I did like FTP and copy my local files and put that in a server?
Yeah, that counts as deploying, I guess. Yeah, like there's no definite wrong way of doing it as long as the end result is the user being able to use it, of course.
Mm-hmm.
So I have quite a good quote. Don't take my word that Einstein said it. I even said Wikipedia, so it might not be Einstein who said this, but software deployment is all of the activities that are involved in making your software usable for the end user. So this is like quite a good general definition of it, because it's like it's any activity you do to make sure that your system is usable in the end. So how do we do it then? Like let's start from the very beginning then. Like let's assume we do have a server that is available publicly, and then we also have our very first Hello World web service website application, literally one page, like super duper simple. What's the simplest thing that we can do? Like it's a tiny hint, it's already been mentioned. So like what is the most simplest thing we can do to deploy this application in order for people to see it?
FTP copy.
Or even, could I use my local computer if I don't switch it on off? Then people can get to my computer?
Yeah, people. That was actually an answer I didn't like foresee, but that is absolutely right. Like you can get people to use your local computer, but let's just, for the sake of the talk, assume that there is a separate web server that you want to use for that. So imagine the most basic operation you do.
So copy over the files, I guess, huh?
Yep, exactly. It's just copy and paste. And that's enough to make it usable by other people, surely. So then we can improve on that by using FTP, for example, so you can do it remotely. So you don't have to drive with your memory stick or with your computer to literally copy it over. So, and then on top of that, we can use SCP, which improves the security, so it's encrypted traffic and you can't see what you're deploying. And then rsync will help you out with only copying the differences, so it'll improve efficiency. But then we might want to add a bit of structure to it. So I hope that everybody has their applications already in source control. That's just another assumption, hopefully so. So maybe maybe copy and pasting stuff will in the long term get messy, and it most likely will. So we can maybe utilize source control to our advantage here. And then we can, in that case, if you're using Git, we can do a Git pull onto the server that we're deploying to. And otherwise, we can do a Git push to that server as well. So if it's like a remote repository that we use. And that brings us on to things that could help us do that with these kind of principles. So for example, Heroku uses Git push kind of mechanics to do that. And Capistrano uses a Git pull to deploy. So just to go over what those two guys are, Heroku is a platform as a service. It understands pretty much all major web frameworks. So once you create your web application, all you have to do is git push to Heroku, and that's your application deployed. It just works. The most basic web applications are free, so it is quite limited in terms of database space and background workers, but in the end it's free and easy, and it's probably the fastest way you can get your basic application out there for people to use, and you get your public link for Heroku, and it's very nice actually.
It's very nice. We are actually hosting our tech blog in Heroku.
Cool, awesome.
The only issue we are having is if you don't use it for some time, then it switches off. And when you go on to go back, then you need to wait a bit longer,
yes.
like a few seconds.
Yeah, one of the limitations is it has to sleep for a while because it's a free instance and they need to shut down the whatever VMs they have it running on. So on the other side, we have Capistrano, a deployment framework. So this requires a server for you to deploy to, so a destination of some sort. So in order to get started with it, you have to capify your project, and that means you initialize your project with certain Capistrano-specific configuration, and that allows you to have access to certain tasks. Like the most useful one would be the task called deploy, which will actually deploy to your remote server. But you can also use these tasks to send remote commands to the server, which is also very handy, like, for example, tailing the logs remotely. Then your application is then managed by Capistrano itself, and it keeps everything in quite a nice structure with every source code release you do is kept in a separate folder up to a limited number of whichever you can configure it however many releases you want to keep, and it also allows you to have shared folders. Like for example, you don't want to redeploy your log files; you just want to use the same ones every time you deploy. So this adds very nice structure. If you're happy to use a framework for this, it's quite easily extensible and could prove to be like very powerful in terms of what it can allow you to do.
So one question around that. So is this Capistrano similar to TeamCity, or is it like a?
No. So this is a purely for deployment itself, and what you do is you specify where my destination server is, and and you map environments to it. So for example, my production server sits there, and all you do is you run your task, which is called deploy. So you do Capistrano deploy production, and it will handle the rest. Obviously, things like booting up your application, routing through Nginx, you'd have to set up yourself, for example, if that's your use case. But this allows you to have a framework for deployment itself. So it handles remote commands, and in the background, as I mentioned before, it does a git pull, for example. So it is based on having a source control available, and it will pull from that. So it's a pull deploy. Okay, look. Yeah. So you got any more questions? Is that cool? Yeah. So what more could we need in that case? Because these two things seem like relatively nice, and it almost seems like we might not need anything else. But then, what if our local environment is out of sync from the deployed web application? And like, what could I possibly mean by out of sync? Like, what things could happen that might cause trouble?
You may have made local changes that haven't been pushed.
Yeah, and not only to the source code itself, but to the configuration, right? To the environment. On top of that, imagine you have different versions of a database running, or different versions of the operating system, or even, in fact, if you're developing on Windows and you're pushing to a Linux server, that's another case where the environment is out of sync. So that could lead to very scary problems where you can't reproduce the bug reliably, for example, which could lead to a whole load of nightmares. So in that case, we have this word, idempotency. But what does it mean? Does anyone know what idempotency means?
know that word.
I think we use that for APIs. Maybe I'm wrong. Like RESTful.
Yeah, APIs is definitely one place you might want to have idempotency.
So the case that it doesn't care about what it's interacting with?
Not quite, but along similar lines.
Yeah, I think Mahmoud was explaining one day this to me around like RESTful APIs, like a put operation is idempotent because you always get the same result.
Yes.
Like a post operation to an API, you may have the same results.
But can you think, so that's in terms of API, but how would you describe that in terms of deployment?
You get the same output when you always give the same input.
Yeah.
So I guess like you have some styles in your application, like some CSS, and when you deploy it to different environments, you get like different styles. The website looks different. Maybe that case, or
so that would be the example of something that's not idempotent.
Something. Sorry, the other way around.
Yeah, so other way around being that if you keep deploying the same thing, it'll stay the same. So in terms of the fundamental description, I've seen quite a good one online. It's called impregnating a cow is an idempotent operation. If you impregnate it once, you can't impregnate it twice, so it won't be double impregnated, if you know what I mean. Like the state of the cow stays the same. So that's the kind of thing we want to aim for in terms of deployment. So once we deploy, we want to have the same result every time.
Yeah.
So
I don't know if the cow you may have different results. No, you may have different number of.
I honestly can't say I've tried. So.
That's a good thing.
Yeah, I hope so. So we can achieve, in terms of deployment, we can achieve that in various ways. So one, for example, would be deploying like artifacts, zips, or like RPM packages, which then you can extract on your target server. So every time you extract them, you aim to have a result like the identical resulting environment. You can also build up virtual machines from scratch. So like you use Vagrant to build them up and deploy them, and that way you'll get in exactly the same deployed service. And of course, I left so much space on this slide for our friend Docker. So I don't really want to go in depth of how Docker works itself because I'm far from an expert. I'm just a fanboy. But for our purposes, we can think of it as a very lightweight and very efficient virtual machine. Some people might kill me for even saying that, but let's just simplify things for now. So how would we use Docker and the containerization technology here? Let's say we are here in our basement writing our program, and in terms of testing it, we would create a local container in Docker, and we'd execute that to execute our service. And when we come to deploying, we just do the same thing on the remote service, where we're deploying. So it's literally the same thing that we're deploying locally and we're deploying remotely. So this way, we have both idempotency and reliable, repeatable environment in which we can run our service. So that's very general hand-wavy basics of deployment. And so then in FIMA-Past, as you all know, we're in a re-architecture phase, and we're trying to move away from our monolithic designs and trying to embrace microservices to the fullest. We all know that we're storing code in private GitHub repositories, and our continuous integration is TeamCity. It does the building, does the running of the tests, and publishing and deploying for us. But wait a second, what is continuous integration? May the audience help me out here. What does continuous integration mean to you guys?
The audience, I think they do it every day, no? Here we have a guy.
No pressure, Josh.
Continuous integration. I think we do that every day, no?
Yeah, okay, yeah, you do it every day. But do you know what it is that you're doing every day?
I think we have some checks, no? We have a bunch of checks that we run, and every time we push a new code, we run those checks.
Then
maybe
yeah. So that's a good starting point of thinking about it. But think of the word integration. Like, what does integration mean to you in terms of developing code?
Smack it all together in one place.
Yes. So and then the continuous part, it means that you're constantly smacking it together in one place. And I also have a nice. So before I get any further, like, why do you guys think it's a good idea to do this?
So you don't end up with merge hell?
Yes, merge hell. Also, you also want to have some sort of central authority to say which version of the code is correct. So that if you say it works on my machine and then he says that it doesn't work on his machine, you at least can refer to your continuous integration to verify which one is the correct version of the software. So I've got another quote by Gandhi this time. That continuous integration is the practice of merging all developer working copies to a shared mainline several times a day, and I'm sure we do it more often than that, even like many times a day as we should be doing. But essentially, it's keeping everything as close together as possible. This might lead to a separate conversation about working on master versus feature branching, but later on. This is meant to be a light dip into it.
So
okay.
Gandhi was doing some continuous integration, no?
Sorry, say that again? Maybe, I don't know. So back to TeamCity, our setup is quite simple, I'd say. We've got one main server that monitors GitHub for changes. Once there are changes, there'll be many Windows and many Linux agents that check them out. Then they would run tests and then go on to do extra stuff that we asked to. So our Docker hosts We have many of those. Those are virtual machines themselves that are specifically there to run your Docker containers. They shouldn't run more than 2 or 3. Only a few containers should be running on it. They are deployed by TeamCity in the end. We'll go into more detail about that in a bit. And they all require plenty of monitoring because they're your babies, they're your products, and you need to be looking after them. So what do we have for monitoring and measuring then? We have Consolidate Logs with Graylog. I'm sure you guys are familiar with that. We also have Graphite for quantitative values, and that means like anything you want to measure, for example, like the response times of web pages, or how many hits you had in a day, or any specific details about any specific endpoints that have been hit. We use Graphite for that, and that provides us a nice query API where we can get the data back out and perform many statistical analysis on it. We also have Icinga and VictorOps, which use data from Graphite, for example, to alert people that are on call. Finally, we have dashboards using Dash&IO, and these dashboards pull the data from Graphite for now, and allow you, instead of having literally just alerts, this is a more proactive way of monitoring your data and your services.
One question about that, Sas. So, Graylog, is it like, can you get dashboards in Graylog? What's the advantage of the Dash&IO as compared to other graphs?
So you can get graphs in Graphite itself. So, but they're not very. I'd say the user experience lacks a bit. So Dash&IO is more provided for the user experience, as well as we've modified that a bit to build up dynamic dashboards from a config rather than you having to build it yourself. And each of those configs could live with the project. So you have your configuration of what you want to see on the dashboard close together with the project itself. So it keeps everything nice and tight together. And also, yeah, all you have to do is just give a configuration, and you'll have a dashboard appearing.
That makes sense.
Yep. So going back to how our visualizing how our Docker containers are deployed, we have TeamCity agents coming around and just remotely deploying our Docker containers to our Docker hosts. But then what happens next? Like, how do we actually expose those services? And how do we get people to actually use them? So enter service discovery. Among other Docker containers on the Docker host, we have a special one called the registrator. So this registrator monitors the Docker host for any new containers being added, and then notifies our central service for service discovery called console. So this stores information about the services, so the containers that run, as well as the nodes / the Docker hosts that they run on. So it essentially keeps track. So this is the persistent keeping track of what containers we have available and which Docker hosts they're on. It also doubles up as just a plain key value store if we need to store any extra information about the services that we have, like for example which blue-green tags to deploy, or just a simple description of the service itself. So then the data in the console can be templated into an Nginx configuration that we can then use to route traffic to our services.
Sorry, Sash.
Yep.
That registrator Docker container, that's communicating with console, right?
Yes. In very like this. Sorry, go on.
Sorry, is it a push or pull? How's it the communication mechanism?
It's a push.
And so if I delete a container or remove a container,
yep,
you're still living in console.
No, registrator will take note of that and deregister it from console.
Okay.
Yeah, so registrator sitting on the
each container.
Yeah, and it listens to the Docker. It just listens for Docker events basically, and then just notifies.
So when there's no events, and it knows what, then it just mentions it across to console.
Sorry. Whenever a command is executed, it will it'll take note of that using the Docker API and just push that up to console.
Thank you.
Yep, cool. Yeah, so we essentially end up with a dynamically built up configuration for Nginx itself. So going next, so we're going back to the diagram. We got our container deployed by Team City, and then we have the registrator container taking note of that, notifying console, which then allows us to create a configuration file on the fly, reload Nginx with the new configuration file, and then Nginx will be able to see the new container itself, and then route outside traffic to our new container. So we have officially deployed our new bit of software. So that's a lot of things, and then we need to make sure that everything is nicely organized, because if things become out of sync, like for example Team City agents have different versions of software installed of them, you can get different results based on which Team City agent decides to deploy or run the tests, as well as we need to make sure that every Docker host contains the Docker registrator container, because otherwise we won't be able to detect any changes on it. So to manage all this, we use Puppet Configuration Management, and what this does is checks in periodically into every machine to make sure that it's in a state that is predictable and reliable. So essentially we don't have any unexpected changes on any of those machines. And if we do want to upgrade something, we upgrade it by changing the Puppet scripts themselves rather than going directly on the machines. Okay, so how do we write code FMP? I'm sure you guys know this better than me. But in theory, with the new architecture, we want to be aiming for continuous delivery, which means short cycles of code and small changes, which will allow us to react quicker to failure and follow up even quicker, which will lead in turn to quicker delivery itself. But we all know that's a dream. And it's something that we should really be just aiming for. So it might not be real right now, but we should always have that in the back of our mind. Okay, so we have a lot of tools that we use, especially coming from the member of the tools team. If microservices were our bricks, the tools are definitely the mortar that holds them together. Every time we have a service or a couple of services that don't integrate well with each other, or there's some sort of funny going on, one of our first decisions is probably just write as tiny as possible tool to make sure that that gap is filled. Like for example, one of our main tools is called Usher. That's our task runner that we use, and it literally just executes the tasks that you specify in a configuration. We decided to roll our own because there was plenty out there, but it seemed like there was not a Node.js based one, which we were most comfortable with. It's also very similar to Ansible, but Ansible itself is a bit too powerful for what we needed it to do itself. Okay, so writing code, I hope we all work in pairs as often as possible, which then encourages TDD and small commits, which in turn gets us closer to the dream of continuous delivery and help us catch failures much quicker. And then when we want to run our applications locally, we would use Usher to run a local development command. For example, Usher run dev. Some of you might have come across that already. That will in turn invoke a Docker Compose layer. That's a layer of abstraction on top of Docker to orchestrate many services together. It's an optional step, but a lot of the times, if you need to have like your service talk to a database service, you definitely want to use it so that the two services can see each other and communicate. And then Docker Compose itself boots up Docker file, Docker containers with the configuration that you specify. So the deployment after that happens automatically. The code in the repository is checked out by the CI after it's published to GitHub. The CI then uses Usher itself to execute test tasks, which might include your unit tests and then your acceptance tests and then smoke tests, and it's up to the project how they've set up their pipeline. And once everything's fine, it goes further to deploy to the actual Docker host using Usher again. So TeamCity literally just works through Usher. So when a new server is new service is deployed, again, this is going back to the registrator thing. Registrator notifies console, which creates a configuration. Well, which then results in recreating the configuration file and then notify Nginx there. So in most of our services, we won't be using blue-green deployment. Avoids having to take down a service in the middle of a deployment. So you don't want to like shut one thing down and bring another one up. So what you end up doing is having the two new containers running side by side. You would run your tests against the new container, like just your smoke test, for example, or whatever else you decide. And once you've confirmed that the new container is safe to use, you would do the blue-green switch. Well, that's done for you automatically by the CI. So in the end, it'll look a bit like this. So looking from the outside, it looks really, really complicated, and there's a lot of moving parts. And things seem like they might go wrong, and to be honest, they do. I'm sure you guys have come across plenty of problems already with this. And yeah, like I can't lie about this being heaven or it being simple, because it's not simple, and there are problems. But there's problems everywhere, and sometimes you do feel like you're wearing the wrong trousers. But you just have to, as Sir Davos put it, you have to go and fail again until you get it right. But when it does work, it feels awesome like this.
Oh. Yeah, definitely there is a moving part there in the middle.
Yeah. Right, thank you very much, guys.
Thank you very much.
Fire off with questions.
Okay, guys, so we have a bunch of people here. Any questions? Any concern? Any?
What's the advantage of using Usher rather than something like Gulp or Grunt?
Say that again?
What's the advantage of using Usher rather than something like Gulp or Grunt?
Oh, right, I see. So the reason why we wanted to move away from Gulp is because that started to become more and more like complicated scripts and code, and the complexity grew to such an extent that people were just scared to change it. So the reason we used Usher and we used YAML files to define our tasks is that we want to reduce like the logic spaghetti logic inside the deployment. So it might look complicated, but it's much simpler than some Gulp scripts that you can have, for example, that have a lot of things going on in them.
Is that so we can move to a more configuration-based type?
Yes, exactly. Yeah, we want to have, in terms of deployment and tasks, we want to have less configuration. Sorry, more configuration and less code itself.
I think Grunt is configuration-based as well. I remember Mobile initially bought the company, but then we moved to Gulp. So could we not have used Grunt instead?
I don't think we considered Grunt at the time. I did mention it. I was even looking at Rake as well, but Rake itself is code, though, to be honest. Going back to Capistrano, that's actually Rake based as well. So those tasks will be code that you run.
Okay.
I think for the maybe in wrong, but I think Gulp and Grunt, we use them for like our JavaScript pipeline. So like bundling the CSS and running some acceptance tests or some unit tests or something like that. It may be that in this case, because it's infrastructure, you want like more like configuration based, so you can run tasks, but they are really like deployment and things like that. The other more like code.
I think they're all task runners though in the end, so it can just run commands as far as I know. So another question I had, the console is creating a config file for Nginx. Is that right?
So the way that works is console itself doesn't do it, but there's another executable called console template, and that is a little thing that runs and monitors console for changes. I'm not sure in depth how it works, but I think like it feels like it pulls it, but it does it in a very nice way. So essentially, you run it, and then you point it to a template, and every time console changes, it updates the template dynamically. So there's tools that are like auxiliary tools to console that do that kind of stuff.
Okay, thanks.
Yep.
Thank you. Any other questions? Moa, you look like you have plenty. I actually go. Do you remember your question?
My question is really open. So my question is, it's not really a question, but I feel like currently we have quite a lot of parts to our deployment thing, and Josh ran me through quite a lot of it. But I don't know if is there any way we can reduce the number of things that we have, or?
To be honest, I think with time, yes, but the stuff that we're working a lot with, especially Docker-based stuff, like Docker itself and the fundamentals of it are pretty solid, but when it comes down to like orchestrating things, it very quickly becomes bleeding edge, and things change really quickly, and sometimes they don't work the way you expect them. So I think with time, when that technology matures a little bit, the complexity for us might be reduced. So for example, instead of using massive Docker Compose files and like Docker hosts all over the place, we can use Docker Swarm and literally have a collated Docker host that we just deploy to, and we don't care about anything else. Everything else is like managed elsewhere, because right now currently you need to know the Docker host you want to deploy to. So I think that's one of the changes that could reduce the complexity quite a bit, but it's not really production ready currently.
Okay. I guess that's always going to be our problem if we're on the edge. We're gonna
yeah, that's the thing. And like I think microservices in general, if you want to if you don't want to use Docker, you would be stuck with either stateful VMs that you change all the time, or you can deploy with Vagrant. And what will happen is just the deployment times will jump quite significantly due to the fact that you have to be compiling VMs now instead of Docker.
Yeah.
I actually had one question around that. I think in the beginning, Sash, you mentioned that we have a limit of like a few services running in every, so a few containers running in every Docker host.
Yeah.
That's actually the point of Docker. Is it not that you can have multiple applications, like different containers in the same host?
Yes, no, you absolutely can, but we've chosen to do that for the sake of isolation and keeping things, keeping the services to themselves. So, for example, if something goes wrong and the containers just stop getting removed, that would fill up the memory on the Docker host. And if we had one Docker host that would just deploy to everything to it, it would just kill all the applications rather than the isolated Docker host that you've been dedicated to. So that's just
but actually, like if you use something like Vagrant, then you could be able to run like at the virtual machine in the host. But then, of course, because it's the entire operating system, then you have a limitation of the things you can run. But like I think the point of this is like you can run hundreds of containers in the same host. Yeah. That's the advantage. So maybe we are limiting our the benefits we are getting from Docker.
I think we had already found a couple of times that containers were actually interacting with other containers on the host, and so we wanted to restrict it until we had a bit more experience with this as well. Like it seems like there could have been a lot of things. Like the memory thing was the first one. I think there may have been even more severe issues where like containers were able to interact. Since they're supposed to be completely isolated, but I don't think they perfectly are yet. And we're still getting a bit of knowledge around this. So for now, we thought it was safer to keep everything completely isolated. The ideal would be have everything kind of shared around, but we just don't know enough yet.
Oh, right.
And I don't think the technology is stable enough yet.
And also, like before with Mahmoud, you were saying like we don't have anything that you still have to say what Docker host to run your container on. I think that like even Docker has something called Docker Swarm for that.
Yeah,
so they discover the hole and when to run it.
That's not quite production ready yet, though. Like Nick literally looks at that every day. I swear to God, every time he comes back, he says, "Oh, Docker Swarm's being updated to do this and this, but it doesn't work yet."
I know that ASOS. There is a company here in London, ASOS. I think the guy I went to a talk, and I think they are using that in production. But
okay, well,
it's recommended to share.
Yeah, you need to be accepting the risk.
Yeah, you also need to be able to know what to do when, you need to know enough to be able to dig yourself out of the hole if you do end up that way. And I think we're still learning about this stuff as well. So.
Yeah. The other question about knowing which Docker host to deploy to is Dave Elliott suggested having like configuration convention-based, so convention over configuration-based deployment as well. So instead of you specifying which Docker hosts to use, Usher should be able to figure out based on the name which Docker host to use. So like instead of you having, it'll just say like anything that starts with the name of the service deployed to that Docker host.
That could be a solution. Maybe I think that could be something like the same way you are able to on the fly generate things for Nginx and console, and you have the registrator. It could be something similar to registrator.
Yeah, well, yeah, exactly. We could, if you want, you can even use console for that kind of stuff, keeping track of where you want to go.
All right.
Yeah, but I think one of the dreams is to have Docker, to at least try out Docker Swarm itself.
Do we have any other questions around here?
One from me. So, have you found the benefit of Docker better, or worth doing Docker compared to just conventional deployment that we?
I have to say yes. So the reason I put that awesome slide on is there was one particular moment where I was taking all of this for granted for a while until I realized that me, Nick, and Josh were all working on a different operating system, and we were writing Ruby, which is notoriously annoying to set up. Like I always call it a heavy door to a cool party. So what was happening is we were running Usher-based development, and every time it was identical, and it was on 3 different operating systems, in which each of which will have its own Ruby problems on it.
Okay. So that Ruby case. Any other examples?
I would also say
people use Docker even if you want to try some new language or something. People use that for not even deployment, to try that language. You just get a container with that language or that framework, and you can try it out straight away.
That stuff down. Also, hopefully, once we've got this stuff a bit more stable, deployments are just going to be so quick because you won't have to build the whole image up each time. You just build up the changes. That should take a couple minutes, and then it's just deploying an image each time, which takes a few seconds. So we should be able to just get out of production in less than 5 minutes. So going through all the steps, plus whatever time it takes your test to run. But that's the dream.
All right. I mean, we're using Docker on the style guide, and after you've done the build, deployment is really quick. So I can see that seems like a good thing.
Yeah, we still speed up the builds now.
I mean, obviously it's a learning thing, so we've gone through quite a lot. Well, things have just changed in the background, and I'm not aware of it, so it breaks my project quite regularly. So I'm always annoying Josh on the regular. So I guess that's fair enough. I'm just trying to see, if we keep aware of the gains that we're getting and making sure.
Absolutely, yeah. I'd agree. The other thing, what I always keep in mind is that this, we're moving to microservice at the same time as we're moving to Docker, and these are 2 steep learning curves. I remember talking to Dave Elliott, and it was literally saying microservices is almost the opposite of having a simple infrastructure.
Yeah.
Because you're breaking up your monolith, and then where's all the complexity going to go?
Yeah.
It's an interesting thing because we have taken on quite a big challenge in terms of re-architecture. It's not just we're going to write our application in Node and we're going to write our Elixir APIs. So here we're using Docker, and we're changing the infrastructure as well. It's just like we're doing nearly everything brand new, and I think it's quite a risk that we're taking on.
Definitely going to be some growing pains.
Yeah, absolutely. Yeah, like again, this is why the talk is called The Wrong Trousers, not Bollywood.
And the other thing, I guess, is before you were saying like this new infrastructure architecture way of deployment, that is also, I think that also affects the entire organization, because we are saying we want continuous deployment that doesn't take long, do frequent releases every day, but I think your entire organization, like the way you work, needs to change as well.
Yeah, absolutely.
Like,
not only that, not only the way you work, but the culture as well. So like you shouldn't be scared about deploying. So like if you're scared about deploying something you think might break, what will happen is that you'll just keep your code away from master, and then it'll take you longer and longer to deploy. But if you write small changes in the less fear-driven way, then you'll find you'll react to your failures quicker, if you know what I mean.
Yeah, it feels like in 5 Pass we are driving the change through the infrastructure, through the deployment, rather than maybe get we don't know about the culture side of things. I guess like some other organizations, they try to change the culture and then get the infrastructure in place to support that culture, if that makes sense.
Yep. Like those are not easy questions, I have to say. Like it's because it's not just the technology factor in your process, it's the people factor too. Because you have to stay open-minded to it all, and like you have to try new things.
Totally, yeah.
It's not so much just trying new things. When you try the new things, you also need to adopt new practices as well. Those need to be communicated, and lots of things.
It's like you bought a new Ferrari. Here we have a new Ferrari car, but we are used to drive like 50 miles per hour in the motor. Even making a bigger mess, I guess. Or you buy a Hummer truck.
Yeah.
You go like, I don't know. You usually pass people in the motorway. Maybe you shouldn't. Okay. Any other things? Any questions, people in the Hangout? If you are still there?
I think they've all fallen asleep.
They have the video to watch. Okay.
Yes, we're still here.
Okay, so thank you very much, Ash, for your time.
Thank you, guys. Thank you for your time.
Best of luck in these new challenges.
Cheers. Thank you.
Thank you very much.
Thanks, Ash. Good luck in the
Cheers.